Now example 2 says factoring trinomials with rational coefficients, or getting rid of decimals and fractions. So basically what they're trying to tell you is you have to first make the numbers simple before you can factor them. So if you've got something that says x squared plus 1.4x minus 1.2, decimals, you gotta get rid of them. So what we're going to do is kind of an opposite thing from something that we've done just recently. Let's say, for example, that I had 3x minus 9. Now you know that I could make those numbers smaller by factoring out a 3. I could just write it as 3x minus 3, right? So I made the numbers smaller by dividing. And I put that number on the outside of the brackets. What we're going to need to do here is make these numbers bigger. So the easiest way for me to look at this kind of thing is to consider what would I have to multiply this by in order to get rid of those decimals. Well, the easiest thing is just 10, right? Then you can just move the decimal over one. So let's give that a shot. We're going to rewrite it as if I had 10x squared plus 14x minus 1.2. Of course, that's not the same value as the original equation, so we've got to say, well, what do we have to factor out of it or put on the outside of the brackets so that if we were to multiply through, we'd be back at that value. So if I want to go from 14 to 1.4, I'm going to have to multiply by 0.1, aren't I? Now I've got sort of a similar pattern to what we are used to seeing, but now the numbers are opposite. There's bigger numbers in here, whoops, bigger numbers in here, smaller number on the outside here. It's okay to have the decimal out here as long as it's not interfering with the factoring as we go through it. Now, you're probably looking at that going, wow, those are really big numbers. I'd like to make them smaller. Once we've done this, we can look at those whole numbers a little more closely, and we can see that there is a common factor that we could factor out. So 10, 14, and 12 are all even numbers, so I can take a 2 out of them. If I take a 2 out, I'm going to have to multiply it by this one on the outside. So I'm going to rewrite this again as 0.2 times 5x squared plus 7x minus 6. So these guys have all been reduced by a factor of 2. The 2's been taken out and multiplied here. And you can see that if you give it a shot, 0.2 times 5 gets you 1. So the original one. 0.2 times 7 would get you 1.4. 0.2 times 6 would get you 1.2. Check it out in your calculator if you don't believe me. Now, we've got a relatively simple equation in here, and just like we did before, we're just going to leave this one outside the brackets. So, this is going to have to be decomp. I'm going to have to ask myself, 5 times negative 6 gives me negative 30. Now what are the factors of negative 30? It's a negative, so I'm looking for a difference. I'm going to keep listing them here. Oh, there we go. 3 and 10 has a difference of 7. 10 has to be the positive one, so I'm going to rewrite this with the 0.2 just on the outside of the brackets, and then 5x squared plus, whoops, that's a negative, minus 3x plus 10x minus 6. So I'm going to look for the common factors between the first 2 terms and then the second 2 terms again. Here I've got not a lot, actually, just x, and that'll give me 5x minus 3 inside the brackets. And here I've got 10 and 6, it's just 2. and that leaves me with 5x minus 3 inside the brackets. So now I know that, and I can make sure that I keep this 0.2 alive and well outside the brackets, and I can just change these ones now so that 0.2 becomes x plus 2, 5x minus 3. Now I've got rational numbers. It's all factored out. Good to go. The next one gives us fractions. Oh no, fractions, no! Not a really big deal though. In this case, especially this one, it just gives one that has a fraction. So I would ask myself, what do I multiply all of those numbers by to get rid of that 2? Well, if I'm dividing by 2, that's what this means, then I would be multiplying that by 2 to get rid of it. So I'm going to multiply by 2. I'm going to go 6x minus, this just becomes 29x now, plus 28. The 29 is going to prevent us from making those numbers any smaller because it's prime factor. But what do I have to put on the outside of the brackets in order for this to all go back to here once I multiply through? Well, I'd have to divide it by 2, wouldn't I? So I can put a half out here. This one's going to suck because you have to use decomposition to find what 6 times 28 is, and then figure out, obviously it's going to be 2 negative numbers multiplying to be a positive, so they're going to have to find 2 factors that multiply to that and add 29. I'm going to give you this one because it's just a lot of work. First of all, this gives you 168. Negative 8 and negative 21 are going to be the ones that work for you. Hopefully you won't get many questions like this during the course of the chapter. They're usually pretty kind. When you find something this big, it's rare. So don't freak out yet. And it's just a process of elimination. So now we've got the negative half, the half. On the outside of the brackets, you've got your 6x squared minus 8x minus 21x plus 28. And we're going to factor the first 2 as usual, leave the 1/2 outside the brackets, and 6 and 8 have 2 in common, x squared and x have an x in common, so I'm left with 3x minus 4 in that set of brackets, and then when I factor these guys, it's a minus sign and a 7 because 21 and 28 have a factor of 7, and then it's just going to be 3x minus 4 in that set of brackets. So it kind of just continues on after that one bumpy patch. Then I'm going to write down my final answer is 1/2 2x minus 7 times 3x minus 4.